Okay, day 5, lesson 5.1, linear functions. So guys, let's talk about linear functions a little bit more detail. This is known as the parent function. The parent function is the original function. Every linear equation comes from this one. Now you guys might know it like this, y equals x. So what does that mean? When you plug in a number, you get the same number as your answer. So when you plug in a 1, in here, your answer is 1. When you plug in 2, your answer is 2. When you plug in 3, your answer is 3, 4, and 4, and so on and so on and so on. So when you graph it, 1, 1, 2, 2, 3, 3, you have this diagonal line that is the parent function of all other lines, every other line. So what changes? Well, a couple things happen to the linear function. The first thing you can do is this. You can multiply it. You can add a multiplier to the front of this, and that'll change the line. So let's see how it changes it. So let's just say I put a 2 in front of it. Okay, what happens if I plug in a 1 into here? Well, that's 2 times 1, so that gives you 2. Okay, what happens if you plug a 2 in there? 2 times 2 is 4. What happens if you plug in 3? What happens if you plug in 4? So now your function is going to look like this. 1, 2, 2, 4. And now your line is going like that. I can't put the other points on there because I don't have space. But let's take a look at these lines. This is the original. This is what happens when you multiply by 2. So what happens is the line that was going like this now is going up faster. It has a bigger slope. Okay, so when you multiply it, it grows at a faster rate. It gets to bigger numbers faster. So like think of it like this. By the time I plug in 4, I get 8. If you had plugged in 4, you get 4. So you're at half the growth you are here. So this is growing twice as fast. And it makes sense because what are you multiplying it by? 2. Growing twice as fast. Now, what if instead of multiplying it, what if you add something to it? What if you add something to the original function? So here, instead of multiplying, I'm adding 2. So let's see what happens. Plug in a 1, 1 plus 2, 3. Plug in 2, 2 plus 2, 4. Plug in a 3, 3 plus 2, 5. Plug in 4, you get 6. So now, if you graph that, 1, 3, 2, 4, 3, 5, looks like this. Okay, so same number, but let's take a look at the differences. The slope didn't change, it still has the same slope, but now instead of starting at 0, it starts at 2. And if you look at it to the original one, the original starts at 0. So if you look at this one, and then this one, what happened? Well, originally it was here, it just got moved up. And actually every point got moved up. So when you add a number to a function, you shift it, you translate it up, down, left, right. That's what happens. So these are some of the transformations that happen with linear functions. So one way to think about it is when you're multiplying it, it changes the slope. But when you're adding something, it changes the starting point or the y-intercept. So if you remember mx plus b, you can think of that the same way. The number that's multiplying will change the slope, and the number that you're adding is going to change the starting point, shifting it in all kinds of directions. So let's give you an example. So let's say they want to take a function. And let's make up a function here. Let's just say this function, keep it simple. Let's just say it's 2x minus 1. Okay, 2x minus 1. Now if you graph that, it starts at negative 1, goes up 2 over 1. Your line looks like this. Okay, that's the function. That's this function, okay? You can change this some more. So let's say you want to add a number to the function. So let's say we're going to add 3 to the function. When you do that, it's going to make a new function. So you're going to change this. Here's how it would look. You're changing your input. So x isn't going to be an x anymore. It's just going to be x plus 3 now. And that's what it's telling you to do. When you're adding a number inside the parentheses, you are changing the input of the function. Okay, but you can't leave it this way. So you have to solve for it, okay? So you can distribute 2x, so you get 2x plus 6. You don't multiply the negative 1 though. The negative 1 doesn't change. It's not in the parentheses. But now you have these two terms, these two whole numbers that you should probably subtract, and you get 5. So when you do this to the function, the new function is 2x plus 5. So if you try to graph this, you don't start at negative 2 anymore, you start at positive 5. But you still have a slope of 2 over 1, so your slope is going the same way. So when you're adding, you're not changing the slope, you're just changing the starting point. Okay, now let's do one more thing. What if I take the function, but now I add the 3 right here. So I'm going to take the function, and I'm going to add 3 to it. So you're going to take 2x minus 1, that's the function, right? That's the original function, and now you're adding 3 to the function. Well, the same kind of deal here. You're not going to change the slope. These two numbers will add up. You're going to get plus 2. Then the g of x, the new function, looks like that. So take a look at the differences. In the first one, I was changing the number inside the input, inside the parentheses. But here, if the number they're adding is outside, you're just adding it to the end. And that's how you get this answer. And then if we graph this one, positive 2 of 2 over 1. Line looks like that. Again, the slope is the same, but the intercept is different. Now here's the thing. It didn't move up 3 spaces though. Think about it. Right here we started at negative 1, right? Okay. Here, it moved it up a lot. Here, if we start at negative 1, it moved it up 3. So they don't move it the same amount. So just be very careful. It shifts it, okay, but it doesn't shift it the same way. This one, when they're adding a number here at the end, this is moving it up or down. When they're moving it inside, right here, this is actually moving it left and right. I know it's weird. Okay, last couple things. What if you're multiplying it by 3? But there's a difference if you're multiplying the outside of the function or the inside of the function. If you're multiplying the outside, let's just say you're doing this to get the new function, then you're multiplying the entire function by 3. So you would distribute, you would get 6x minus 3 is your new function. Now you changed everything. You have a new slope and you have a new starting point. So multiplying it changes it a lot. Now, the difference if you did it here though, what if the 3 was just inside with x? Well, what they're saying here is when you take your function, you're replacing x with 3x. So the number's only going to affect the input. When it was here, it affected the whole thing. When it was on the outside, it affects the whole thing. But when it's on the inside of the parentheses, it's only affecting the input. So you multiply this. This time, this doesn't change, but your slope changed. So you'd have the same starting point from the other one, but you're going to have a bigger slope. So these are the different ways you can transform a function. Multiplying it, adding it. You can even multiply with a fraction. You can add a negative number. There's all kinds of things you can do to change the function. But it all has to do, where is it being affected? Is it in the parentheses? If it's in the parentheses, it's going to affect your input, like this one. If it's outside the parentheses, it's going to affect the whole thing.